This next presentation is about the other way around, a concrete case of Brazilian deep tech that has been successful, is being successful in the German market. So I'd like to welcome on stage Mr. Taiguara Tupinambás. He is the Chief Commercial Officer of the Brazilian deep tech FabNS. Taiguara, the floor is yours.
So thank you very much for the opportunity. For me, it's truly an honor to share with you a little bit of FabNS history and our successful collaboration with the German R&D landscape. But before diving into our history, I'd like to give you a little bit of context on what we are and what we do. And first, a disclaimer that we have a similar problem as BASF or BASF, because we got a little of confusion with our name. Some people call us FabNS or FabNS, even FabNano. We call ourselves FabNS, but you can call us whatever. If you want to buy our products or invest in us or collaborate anyhow, we'll be happy. But as Pedro mentioned, we are a deep tech startup. And as most of the deep techs, we are a spin-off, an academic spin-off originating from the Federal University of Minas Gerais. And we specialize in scientific instrumentation for the advancement and empowerment of nanotechnology. So our core mission is to design, to develop, and to market a large and cutting-edge nanoscope that is highly complex, has an exclusive and patented technology, and has extremely high added value. This advanced equipment, you can see an example of one of FabNS instruments called Porto. This one is installed at a multi-user laboratory in UFMG. And this equipment enables researchers to explore and to gain profound insights into the chemical and physical properties of materials in a nanoscale. And why is that so important? I guess most of you have already heard that nanotechnology holds a huge transformative potential. There's a study of Bain Company that puts it on the same level as electricity when it comes to the disruption it may achieve. And it might become the next big thing, and we are betting on it. And actually, you can already witness some of its achievement and some of its applications in the most various fields. I brought here some examples to illustrate it, and all the examples are cases that we as FabNS are somehow involved with. There is this Canadian company called Zentech. They are leveraging and using nanotechnology to enhance the properties of their protective materials, and we are actively supporting their R&D efforts. There's the renowned nanomaterial called graphene. I think all of you also must have heard about it. And graphene has already found its ways into many applications in the most various fields, and our technology can play a crucial role in the characterization and quality control of graphene products as well. Our nanoanalysis capabilities can also extend to environmental challenges, like cleaning oceans from micro and nanoplastics. We have ongoing collaborations with researchers from Spain to tackle this pressing issue. And we also have started a collaboration with a Brazilian university to use our technology to enhance and to advance the agricultural business. And if you think about it, nanotechnology can really revolutionize virtually every industry sector there is. But there's a major challenge when it comes to handling handling materials at such a minuscule scale. That is because of its size, obviously. So just to put into perspective, 1 nanometer can be almost 100,000 times smaller than a single strand of hair. And yet, our technology can provide optical images at such a scale like no other technology can. Just to illustrate the comparison, here's a nanomaterial imaged by traditional microscopy analysis. You can see the reference here on the strand of hair. And in the image below is the result produced by our system, and you can finally see it's a world map. It's a graphene sheet bombarded with ion of heliums to produce defects in a really controlled manner. And you can only see these finer details and a wealth of additional information with the results from our system. And here's another example of the logo of our beloved university, UFMG, and how it compares between the traditional analysis and our results. And here's an E. coli bacteria, just to give a perspective of the size. And all this journey to make us to reach this point, it started 2 decades ago, when Professor Ado Jório from FMG and our main scientific advisor met a German professor called Professor Achim Hartschuh in an international conference. And in this conference, Professor Ahim gave a lecture about this groundbreaking technique called TERS that would be capable of delivering optical images in a nanoscale, something that was unimaginable at the time. So Professor Aldo got really interested and he started a series of international missions. He met with other international professors, such as Professor Stephanie Reich, that was in fact the PhD supervisor of Professor Sebastian Higg. It's our very first customer from Germany. And interacted with other universities, such as at the Zurich. And you can see some of these pictures of his students and himself traveling back and forth. So he started to invest to explore this technology further, and in 2006, Professor Aldo and some of his colleagues established the Laboratory of Nanospectroscopy, which is the FabNS at FMG, and that's why our name is FabNS. We pay a tribute to the laboratory that we originated from. And at the same year, Brazil started a research network, a national research network called SPM. Oh, here's the picture of the FabNS with our partners at FabNS. And here is an example of this research network for scanning probe microscopy, and it provided us with the initial resources for materials, equipments, and scholarships as well. 2 years later, the ADOS group published their first impact paper on nature materials using TERS experiments conducted abroad. On the next year, the FabNS assembled the first TERS system in the southern hemisphere. And we also produced our first nano-optical images. So you can see, again, the difference between traditional analysis and the details you can get with our TERS systems. So for the following years, we kept on these international missions. We assembled our very first and own scan head, which is a critical piece of the equipment. We also filed for the first of many patents in this period. And in 2015, we got a major milestone for the development of the company. That was the publication of Thiago Vasconcelos' PhD thesis. Thiago is also a co-founder and partner at FabNS. We are 3 PhDs, and I'm the only one that stopped at a master's degree. But Dr. Thiago's thesis described the state-of-the-art nanoantenna for TERS operation, and which would be nowadays an exclusive technology for FabNS. And this nanoantenna is responsible for ensuring the quality and consistency of the results that we can deliver. So with all these achievements, the group started to develop the business plan of a spin-off and what would become FabNS. We also reached an agreement with Embrapi and Codengi. One of the Embrapi units is actually Senai Cimatec, that we have a representative here as well. And this agreement was really important to secure us for the necessary resources and investments to significantly elevate the technology readiness level of our system. It was during this period as well that we filed for the patent of the nanoantenna specifically, which is probably the most important patent we have so far. And then we began this journey to develop the commercial prototypes of the technology. It was also when I joined the group in 2018, and it took 3 years of intense and multidisciplinary work. At the peak, we were 60 people, 60 professionals from the most varied domains, including electronics, mechanics, optics, firmware, and software development. And we successfully managed to deliver 2 commercial prototypes, both of which are installed at FMG. During this period, we also achieved significant scientific achievements, including the cover paper of the Journal of Physical Chemistry Letters, and also we had the honor to be at the cover of Nature magazine. I'm sure you've heard of it. It's the most prestigious and important scientific publication of the world. And we got to see our nanoantenna featuring at the cover. It was actually the second time a Brazilian research group achieved such an honor. But maybe the most important achievement of all was a letter of intent that we got from Professor Sebastian Higg, establishing his interest in investing in buying one of this technology we were developing. So with the project concluded and the commercial prototypes developed, and also with the letter of intent at hand, we secured a seed investment from Fundepar, and in 2022, we officially founded FabNS. We are based in Belo Horizonte Technology Park. São Paulo, as mentioned here, is actually really an interesting hub, but Belo Horizonte is also a very important hub for startups. And our base is at BH Tech, the technology park from Belo Horizonte. And what was once the letter of intent became our first commercial order for a Porto unit, destined to Humboldt University of Berlin. So after some times and many challenges, especially with the microchip crisis worldwide, we're talking about more than 4,000 electronic components needed to produce our system. But nevertheless, we managed to produce our first commercial product. And you can see here in this beautiful Made in Brazil package, the nanoscope ready to be shipped to Germany, and almost every collaborator from FabNS as well in this official picture. In a couple of days, it arrived at University of Humboldt. So you can see Professor Sebastian Higgs' group, very happy customers indeed. And it was just a couple of weeks ago it arrived there. And we already helped them unpackage in the box, and next month we'll be here installing and commissioning the system so it can produce some cutting-edge science, I hope. This year we also got another scientific achievement, another cover paper for Nanoletters, important scientific publication as well. And we added some solutions to our portfolio, namely characterization services to attend the industry, and also some data analysis software that we also sell. And now for the future, I think the sky's the limit. We are focusing on increasing our installed base mainly, especially in Brazil. We have some advanced negotiations with research centers and universities in Brazil to procure our system. We are also looking to establish an international headquarters, and most likely it will be in Germany, so I think I can meet a lot of interesting people that already participate in the panel and in the talks early along. And this international headquarters will be really important for us to increase our R&D cooperation and also increase our market reach, obviously. We have ongoing projects in Brazil, grant projects, to add new functionalities to the system, add new products, and further the innovation overall. And we are also exploring new investment rounds to accelerate our growth. So just to wrap it up, this successful journey from LabNS, then to FabNS, and then back to a lab at HU Berlin, is the result of collective effort from individuals from all around the world. And it was only made possible through substantial public investment. So as Mr. Guila Calheiros mentioned earlier, the amount of investment we're talking about in Brazil, it was already happening like 20 years ago from the beginning of the century. And it was really important to make it happen. We're talking about almost 40 grant projects, most of them funded by government agencies and institutions in Brazil, but also several from Germany and other countries. This whole process resulted in the filing and granting of 16 patents overall. And it is also a very illustrative example of what Ambassador Laudemar mentioned, from paper to product, but it's a little bit more complex. In our case, it began with international cooperation that led to quality research, which became papers and impactful publication, which in turn led to patents, and then intellectual property licensing, and finally became invoices. And what was once a really unbalanced equation of technological imports from Germany to Brazil, as mentioned a lot in the event yesterday from the government meetings they had, they talked a lot about this imbalanced equation, now may start to balance out towards a more fruitful and more equitable relationship between our countries. So with that I end. I have here our socials if you want to follow us and get the recent news, and my email's there as well if anyone wants to talk, and I'll be happy to answer your doubts or continue a conversation. So thank you very much.
Is it on? Yeah. So maybe just one comment. I mean, we've been talking a lot about innovation of how it transfers, but I would like to point out there is also kind of a structural problem in a certain sense that we need to look at. So imagine you're working at a German university and you're trying to send money advancement to a Brazilian startup in order to purchase an instrument. Now, if you've ever been to a German sort of official organization, you realize that this may be a bit difficult. So I think we also need to look at improving those structural problems, being able to send money to Brazil, having bank guarantees that work for German institutions. And I think this is also an important point to look at on the more practical level. Thank you.
Just adding up, I think Brazil, for instance, is really well prepared to send money abroad to buy and to import technology. But I don't think the countries from Europe, for instance, are prepared to import technology from Brazil in this type of technology, at least. So it's really an important point, and it was really a huge difficulty we had throughout this process of exporting an instrument to Humboldt. So thank you for the contribution.